Hello, and welcome to the Ax-4 Science on the Mission press conference. I'm Alexis DeJournette from Axiom Space, and we're excited to have you join us today to discuss the microgravity research, scientific experiments, and tech demos planned for Axiom Mission 4, which is scheduled to launch on May 29th at 1:03 p.m. Eastern Time. This mission will feature around 60 scientific studies from 31 countries, setting a new record for the most research activities conducted on an Axiom Space mission to the International Space Station. Today, you'll hear from Axiom Space's Chief Scientist, Lucie, as well as research experts from the International Space Station National Laboratory, the European Space Agency, Burjeel Holdings, Sanford Stem Cell Institute, and the three nations flying on Ax-4, India, Poland, and Hungary. We look forward to today's discussion on Ax-4 research and the collaborative efforts of three nations as they embark on their first mission aboard the space station. Before we open the floor for questions, Axiom Space Chief Scientist Lucie will provide opening remarks and introduce today's speakers. Over to you, Lucie.
Thank you so much, Alexis, and welcome everyone. We are delighted to be here. So good morning, good afternoon, good evening, wherever you are. Thank you so much for joining us for this science press conference on the Axiom 4 mission. So to set the stage, as a reminder, Axiom Space has so far completed 3 successful missions in 3 years, with our next mission, as Alexis said, targeted to launch next month. We have completed to date over 100 research-related activities with more than 50 research partners, as well as more than 75 outreach and media engagements. So we've reached a global audience with our missions to date. These missions have represented 11 nations, so we are opening the door to countries where previously access to space has been through the ISS partners, but we're opening the door to new countries, institutions, and individuals that can bring new ideas that can really fuel an economy beyond Earth. Not only that, but these private astronaut missions actually make us ready as ourselves for Axiom Station. So our private astronaut missions are designed to flesh out and test procedures, communications, coordination, training, and so much more, so that when Axiom Station is ready to become independent from the ISS, the private astronauts, the ground teams, the crews, and the platform that they support will be fully functional and ready to hit the ground running to execute on day one on behalf of our customers worldwide. Now, Ax-4 represents a very significant journey in our milestone in our journey to advance human space exploration and scientific discovery. As Alexis said, this is a record-breaking mission with over 60 scientific activities and studies representing 31 countries, which is the most research and science-related activities conducted to date on an Axiom Space mission. So it really does highlight how many people involved around the world there are in this global mission, and how this is such a significantly global and collaborative effort to advance microgravity research in low Earth orbit. We've also been really excited about the enhanced in-country participation from India, Poland, and Hungary. By bringing together stakeholders from across the country, Ax-4 is showcasing the value and opportunities in microgravity research, which will enable a dynamic and sustainable space industry worldwide. So the Ax-4 crew members will represent their nations in low Earth orbit. They'll conduct lots and lots of scientific experiments, and they'll do an awful lot to showcase what their countries can do. Their work will contribute as well to the global body of knowledge and research and showcase the capabilities of their home countries and advance them in space research. We're also very excited at Axiom Space to be launching a few of our own research studies as well. So I shall leave it to Dr. Catriona Jameson to talk about some of the cancer research that her team is doing, but we're also very excited to be launching a project called Sweet Ride, which is paving the way towards flying the world's first diabetic astronaut. I'd also like to give a shout out to all of the research partners and country leaders that we've worked with for this work on this mission. We're extremely grateful to the ISS National Lab, ESA, NASA, HUNOR, ISRO, all of our amazing implementation partners, as well as all of the fantastic global teams that have been developing and are going to be flying this amazing scientific research. So with that, I'm pleased to introduce the distinguished participants who are joining me today. We have Dr. Michael Roberts, the Chief Scientific Officer of the ISS National Lab, Mr. Tushar Phadnis, the Group Head for Microgravity Platforms and Research at ISRO. We have Dr. Angelique van Oombergen, Chief Exploration Scientist at ESA. We have Monica Balashek-Zimmerman, the Head of Research and Innovation Department at PULSAR. Dr. Balazs Nagy, Research and Development Director of Hungary, Dr. Mohamed Fitian, the Chief Medical Officer for Burjeel Holdings, and Dr. Catriona Jameson, the Director of the Sanford Stem Cell Institute at UCSD. So we all look forward to answering the questions about the research that's going to be taking place and the exciting work that the teams will be leading. But now I'm going to hand it over to Dr. Roberts from the International Space Station National Lab for some remarks before we move on and then begin the Q&A. Over to you, Mike.
Thank you, Dr. Lowe and Alexis and the incredible team at Axiom. It's indeed an honor to be able to join you today for the science brief ahead of Axiom Space's fourth, and you heard, record-breaking private astronaut mission to the International Space Station. Here at the ISS National Lab, we are incredibly excited about this mission and the ability of partners like Axiom Space and the incredible partners across the world to send more innovative research to the space station to be supported by the next four-person private astronaut crew taking orbit on a SpaceX Dragon spacecraft to utilize the International Space Station. I just wanted to remark again that we all enjoy the benefit of nearly 25 years of continuous human presence in space made possible by the international effort to build and operate the International Space Station. We look forward to continuing on the great success of the International Space Station with commercial space stations such as the Axiom Space Station in the near future. To date, more than 4,000 experiments have been conducted on the International Space Station, including fundamental research in the life and physical sciences, and including translational biomedical research, materials investigations, and advanced technologies for improved communications, computing, and manufacturing. You'll hear a bit more about those today from Axiom's partners on this private astronaut mission. With that, I'd like to turn it over to Mr. Fadness.
I'm glad to be here to represent ISRO and speak about the Indian science experiments on the Ax-4 mission. On our maiden mission to the International Space Station, we have a set of experiments being investigated by some of the leading academic institutions and research labs from India. The experiments range from research on growth of microalgae and cyanobacteria to muscle regeneration experiments, sprouting in space, studying resilience of tardigrades, seeds experiment, and human-computer interaction in space. Keenly look forward to the outcome from these experiments. So with this, I hand over to Dr. Angelique van Ombergen.
Thank you very much, and hello everybody. It's my pleasure to be here today, and I just want to say also that we're very happy to be working again with Axiom, in particular also after the great collaboration we've had on the Axiom 3 mission with the Munian mission. Just to state that from the European Space Agency side, we're very happy to have a scientific complement that focuses in particular on health research, looking into physiological adaptation of both bone, muscle, and the cardiovascular system. This is a key priority for us, also in relation to our strategy in keeping our crew as healthy and performant as possible across our missions in the EO, but also, of course, to use this as a preparatory activity for deep space exploration. I'm, of course, also very happy to be here together with additional colleagues from Europe. And I want to extend also big thanks to our colleagues from the Polish Space Agency, with whom we have worked very closely together in selecting also the science for their mission and in helping them to come to fruition. And with that, I would like to hand over to my colleague, Monika Banaszek-Zimmerman. Thank you very much.
As it was said already, good morning, good afternoon, and good evening to everyone. It's a big pleasure to be here. Thank you, Angelique, for the kind words and the thanks. We are thankful also for your support in having our mission. Our complement is the 13 experiments provided for the mission, a part of the Axiom 4, the IGNIS mission, which makes the space open for everyone, and we trust for that very much. This is a historic moment for Poland to join this mission, to be able to, after 47 years, be present on orbit with our astronaut, completing different interesting experiments. This couldn't be possible without the cooperation on our domestic market, without the support of the Ministry of Economic Development and Technology, without cooperation with European Space Agency, and of course, what is very much important for us, without the involvement of our network of scientists and engineers and innovators who submitted many proposals for the experiments, and from them we have selected 13 that will fly very shortly on the 29th of May with Axiom 4. Our experiments are very unique and are coming from the biotechnology, technology, material sciences, and also the very important part is the part focused on the physiology, human psychology, and all this human research that we will be developing also together with Visa and other partners at the throughout the mission. So a big pleasure to be here and answer all the questions. And now I will give the floor to Hunor and Dr. Balázs Nagy to speak about his experiments. Thank you very much.
Thank you and hello. My name is Balázs Nagy. I represent and lead the Hunor Research and Development team. We are responsible for the Hungarian scientific activities on the ISS. Our research astronaut Tibor will be flying with around 25 Hungarian experiments covering fields like human research, life sciences, fundamental physics, technical demonstrations, and educational projects, all developed by universities, research institutes, and private companies. So it's an honor to be here at this event. Thank you for having me.
Hello, everyone. As mentioned, my name is Dr. Mohamed Fitian. Along with my role as a chief medical officer, I also work as an internal medicine consultant physician. And I'm pleased to join you today on behalf of Burjeel Holdings, one of the leading healthcare providers in the United Arab Emirates, in UAE, and the region. Our experiment with Axiom Space is called Sweet Ride. It aims to explore the feasibility of supporting astronauts with insulin-dependent diabetes in microgravity. This is being done by two ways, by validating blood glucose monitoring, data transmission, as well as insulin viability aboard the International Space Station. This effort reflects our commitment to advancing medical science and promoting greater inclusivity in space exploration. We are hoping to get the data that will help, hopefully, the next flight to send the first astronaut, diabetic astronaut with type 2 diabetes to space, and also to get some information and feedback from this study to hopefully implement this for our patients on Earth. And this, again, reflects the UAE vision to expand the space exploration. I'm very happy to be here with you today. We'll be happy to answer any questions. And with that, I would like to turn it over to Dr. Jamison.
So much. Similarly, I'm a physician. I'm the director of the Sanford Stem Cell Institute at UC San Diego and also the co-founder of Aspera Biomedicines. And we're thrilled, Lucie, Mike, and the rest of the team, to be working with you yet again. This is actually our fourth mission with Axiom and onto the International Space Station with something I think trumps AI every time, and that's natural intelligence. So we're very excited to work with the Axiom astronauts and the ISS crew to be able to test a new drug called rubexinib, which prevents cancer from cloning itself. We discovered this with Lucie and the team in our Axiom 3 mission, that it was a cancer kill switch. This time we're testing patient-derived tumor organoids, so they're mini tumors, to see is it equally effective across a broad range of tumors. We will also be studying the astronauts to see if their stem cells get stressed in space and whether or not we can develop countermeasures for that. So we are on the right trajectory, I think, to help patients in the clinic to realize that space matters, and it actually accelerates timeframes for finding new therapies, not just for cancer, but for all of us as we age to hopefully turn back the clock. I'd like to thank NASA for in-space manufacturing funding, CASIS, the Center for Advancement of Science in Space, for Igniting Innovation funding, and of course, Lucie, for all your partnership and your team at Axiom. Thank you. Back to you, Alexis.
All right. And we will now open the floor to questions from reporters. If you have a question, please use the raise your hand feature or submit your questions in the Q&A function. If you are joining on your phone, please press *6 to unmute yourself when called on. Please state your name, outlet, and to whom your question is directed. Let's begin. All right. First up, we will have Paulava Bagla.
Thanks a lot for having me for the press conference. I look forward to a great mission now that we have a date in mind. It's just a month away. Couple of questions. My first question is for Mr. Tushar Fadnis from ISRO. Mr. Fadnis, any reason why ISRO has decided not to do a full-fledged experiment on yoga in space? Especially because India's first astronaut did yoga on the Russian mission. And moreover, Prime Minister Narendra Modi is very fond of yoga. So why have we not chosen to do any experiment on the physiology and biology of yoga in space? I have more for you later.
Hello, Baglaji. Thank you for the question. Yoga is an integral part of training of the Gaganyatris for Gaganyaan program, for the Gaganyaan mission. All the astronauts, including Shubhanshu Shukla, have undergone training in yoga. While human research areas in the areas of Ayush, including yoga, is a matter of keen interest to ISRO, such studies typically involve very long gestation periods and require constant interaction between the investigator and the astronaut, which would have been a limitation for Ax-4 mission, given the specific training requirements for the mission and comparatively shorter time frame that we had to conceive and execute a human research experiment of that sort. However, ISRO continues to be interested in this domain, and we encourage the Indian investigators who would be interested to take up in taking up this research. Thank you.
Thanks a lot, Tushar. I had a follow-up question for you. Why has ISRO chosen to do only 7 experiments? We just heard Hungary is doing over 24 experiments. So what will be the big takeaways from Group Captain Shubhanshu Shukla flying to space?
So the 7 Indian experiments which are flying on Axiom 4, this was selected following a due process, which included inviting proposals from the leading Indian academic institutions and R&D labs, a thorough review of each of these proposals by experts drawn across various domains, because this is quite interdisciplinary in nature. The suitability of this experiment for a short duration mission like Axiom 4, the maturity and readiness to meet the deadlines which were quite limited, the safety protocols which are typically involved in such space station missions, and its relevance. These were some of the factors which were considered to draw up this final list of experiments which are selected. On the outcome of these experiments, this will definitely advance our understanding on various areas like crew nutrition, cognitive abilities in microgravity conditions, the sustainable space farming, sustainable life support systems, which will be very crucial when we talk about sustained human presence in space, and many more similar areas and adaptations to extreme conditions. So this experience will also strengthen our preparedness for conducting microgravity experiments on board our own Bharatiya Antariksha station as well. And apart from this, the outcome of these experiments will also benefit other stakeholders of microgravity research like biotech, agri-tech, or pharma sectors and similar sectors who are basically the stakeholders. So all this aligns well with ISRO's aim to foster a microgravity research ecosystem in the country. Thank you.
Thanks a lot. I also had a question for Dr. Lucie Lowe. But before that, one more quick question for Mr. Tushar. Mr. Tushar, the experiments you have chosen seem very, very elementary. Even school and college students in America are doing more advanced experiments at the International Space Station. Why did we choose so elementary experiments?
Probably I would differ on some of the things. Some of the experiments like muscle regeneration are quite involved. And as I mentioned, we had our own criteria for selection. the time constraints, and this was our maiden attempt in doing a full-fledged microgravity experiment on the International Space Station.
The general point that research in space is really very difficult. Everything behaves differently. The pipetting that might be very standard in a lab here on the ground or even in a high school is not the same as it's done in space. And so there's a lot of things that are very different about doing science in space. So things that can seem very simple or very basic to do here on Earth can actually be extraordinarily complicated in space. And so one of the things that all of our partners and all of our teams are aware of is how they have to translate everything they do into being able to functioning in a microgravity environment. And so all of the research that's being done on Ax-4, even if the actual activities seem quite straightforward up in orbit, they're probably very complicated, but also a lot of the analyses and a lot of the insights into what the outcomes of the research actually is may not happen until the research comes back down or until the results are returned and then the analyses are performed. So all that to say is that I'd like to think that all of the research that's being performed on Ax-4 is very exciting and also very difficult. So we want to extend our hearty congratulations in advance for all of the teams for all their hard work.
Thanks a lot, Dr. Lucie. That was a valid explanation. One small question for you. Out of the 60 experiments on Ax-4, which are the 3 of the best innovations in your mind? And don't give me a phonetically correct answer that ISRO's experiments are the best.
I could not possibly pick 3, just 3. There is such a tremendous amount of science. Every single research portfolio has highlights for me personally. I am personally very excited about our Sweet Ride experiment because for Axiom, it means that we are enabling new opportunities for a more diverse crew to fly in future, as well as translating those results back into hopefully impacts for diabetic patients here on Earth. But Dr. Fitchen will talk more about that. I'm also tremendously excited about the work that Dr. Catriona Jameson is doing at UCSD, looking at stem cells, looking at cancer, looking at how drugs can affect cancer in space. But again, I could talk about these all day, so I won't. I don't want to go through and highlight every single project that I love because I would be here all day and we still have lots of questions to get through. So thank you for the question. But Alexis, I believe we're going to move on.
Thank you. All right, next in line is Jonathan Surrey.
Wonderful. Thank you so much, Alexis. This question is for Dr. Fitchen and also Dr. Lowe, if she wants to weigh in on it. I'd love to know more about the logistics of the diabetes experiment. Which astronaut or astronauts will be wearing the glucose monitor? And is this something that they will be wearing at a certain phase of the mission, or will it be from launch to splashdown? And then big picture, the philosophy that's driving this as far as expanding space flight, expanding the medical qualifications for space flight. Thank you.
I will hand over to Dr. Fitchen to take that question, but before he answers, I will just point out that we cannot identify any crew members that may be taking part in human subjects research. So we will not be naming the crew member that may be taking part. That said, I'll hand over to Dr. Fitchen to tell you more about the exciting project. Thank you.
Exactly. Thank you for clarifying this point, and thank you for the question. Yes, we are very excited about this experiment. So we will have some of the members will be wearing the continuous glucose monitor, and we will be monitoring their blood sugar while they're in the space. And the purpose is to see the effect of the microgravity. So, you know, space is a stress test for the body. So when it comes to microgravity, change in the temperature, radiation. So we want to see how will the body respond to this, and how will this affect the metabolism of the blood sugar. We will be also sending, the insulin pens, and those will be tested on the ground, and then after the flight returns. And regarding the second part of the question, I think it was, sorry, can you repeat that, just the second part of the question?
Yeah, second question is just big picture. What's the philosophy that is driving this experiment in terms of expanding who meets the medical qualifications for space flight? I know right now, if you're applying to be an astronaut with NASA, having type 1 diabetes is an automatic disqualifier. Hopefully this is able to expand the qualifications. Just tell me about what's driving that philosophy.
Exactly. So we were thinking about in two ways. We were thinking, how will this, as you rightfully mentioned, in type 2 diabetes who are insulin dependent, who were excluded before, hopefully give them the opportunity to be included and then to go to space, to break these barriers of having health issues and chronic diseases was for a long time was a barrier for many people. So hopefully we will be able to help this group of people. And we also are looking at our patients here on Earth. We would like to see how, again, this stressful environment is affecting the metabolism of the blood sugar. And hopefully we will be able to learn something here to bring it back and to implement it to our patients when it comes to insulin or coming, like, for example, the monitoring as well. We have patients here who live in underserved areas, remote areas. If we are able to monitor the blood sugar in a way from here for astronauts in the space, hopefully this will help us also to come up with some solutions here down in Earth.
And if I could just follow up with that last statement, what are some of those remote places on Earth that this might have applications?
I will give you an example from where I am in. So now I'm in United Arab Emirates. So we have a big cities, but we also have oil fields. We have some desert camps where the workers work there and they have chronic diseases and they have some accessibility issues to hospitals and healthcare providers. So we can think of them as patients who we can serve with remote monitoring. Again, with this study, I know they're not diabetics, but this will help us to monitor those diabetic patients here on Earth remotely through the CGMs and the remote monitoring systems.
Jonathan, I just have one further translational aspect to add that we're quite interested in. So the continuous glucose monitor actually works by monitoring the interstitial fluid within the body. And due to the fluid shifts that take place when a human enters microgravity, this could actually change the concentrations of some of the glucose or the items that are being monitored by the CGM on the ISS. And so what that means is we suspect that might actually translate into some insight into continuous glucose monitoring of patients that might be immobilized or in bed for long periods of time. It might simulate extended bed rest. So we're actually also hoping to get some insight into how a continuous glucose monitor, how the readings might be affected slightly differently and therefore potentially impact some patient care down here on Earth as well.
Thank you. All right, next in line is Sibu Tripathi.
My question is for Mr. Tushar Fadnis from ISRO. What are the big expectations from the experiments that are being sent to space by ISRO, and how will they enhance India's Gaganyaan mission? And secondly, will all the 7 studies being sent to IS by ISRO will be performed by Captain Shubhanshu Shukla, or will there be participation from other astronauts as well?
So all the experiments, yes, will be performed by Shubhanshu Shukla. What we see, this ISRO, we have our own roadmap, which aims for a sustained human presence in space. We have plans for having our own space station. Now, there are a lot of technologies which are needed to be developed. So some of these experiments directly align with that. For example, the studies on cyanobacteria and microalgae, we look for getting the fundamental knowledge on bioregenerative life support systems, which will be of importance for sustained human presence. The research on tardigrades will help us to understand how these extremophiles withstand extreme environments, which can give clues how humans can sustain similar harsh environments. There are experiments on the seed experiments, which look to have the seeds exposed to microgravity conditions, bring them back to Earth, grow plants from these over generations. and see what are the effects of microgravity on the generation of plants. Sprouting salad seeds, which has direct relevance for crew nutrition, which will help us to have an India-specific food for our own astronauts for the future missions. And then we have our own human space missions coming up. So this will also give us an operational experience of conducting the microgravity experiments in terms of the protocols, the various safety procedures involved, and definitely it will help us to plan our own experiments on Gaganyaan as well as on the Bharatiya Antariksh Station.
Okay. And I'm now going to take a question from the chat from Marcin Haber. I believe this one is going to be for Dr. Van Ombergen. The Ax-4 mission will mainly carry experiments related to astronaut health. Is this a clear signal that ESA is preparing for longer missions in space? If so, what is the goal?
Yes, thank you very much for the question. So, of course, crew health and performance is a very high priority for the European Space Agency and its member states, because obviously within the Human and Robotic Exploration Directorate, we have a clear goal. We now have a strategy which is called the Explore 2040 strategy, which outsets that we want to have, let's say, exploration within lowered orbits, longer term, and utilization as well. But we also want to go beyond lowered orbit. We want to go to the moon, to the lunar surface, and we eventually want to go to Mars. So we are currently indeed preparing all those elements. Lowered orbit is a very important platform in a sense that it can help us to gain key knowledge that will help us to prepare for those future missions, and that it can also help us to de-risk those key missions. So I think this is a very important, let's say, thematic for us when it comes to crew health and performance. That's also why you see in the Ax-4 complement, indeed, activities focusing particularly on physiological adaptation, but also looking into potential countermeasures. Because again, this for us is a key priority. We want to do responsible exploration, keep our crew as healthy as possible. And this, of course, requires that we have this on an evidence-based manner where we can also get the data from experiments. Thank you very much.
Thank you. All right, next in line is Jeff Faust.
Morning. As a question for Dr. Lowe, you mentioned that Ax-4 will have more experience than any of the previous Axiom flights. Curious what you have lessons learned from the previous flights or other steps you've taken to sort of optimize the amount of science that you can do on this mission, or how much of it may have to do with just the mix of research payloads that you're flying on this flight. Thanks.
Thank you. That's a great question. And so this is our fourth mission to date, as we've said, and we have learned a tremendous amount, not only at Axiom, but also in working with all of our customers, all of our partners, with our tremendous colleagues at the ISS National Lab, and also with NASA, who have been incredibly supportive and have worked alongside us all the way to allow us access to their facilities and to help our crew get integrated and functional on board so that they can get this research done. The reason that this mission has so many research projects is partly as a result of the lessons learned that we have taken on board, and we've streamlined the processes. We've figured out how to do things more efficiently. We've figured out how to work with everyone more quickly and more efficiently to get research up onto space. But it's also it often comes back to the question of prioritization. People wonder, okay, well, how do you prioritize the research that takes place on a mission? And there's a few factors that go into that. And so one of those is when we have a research portfolio that comes in from a government funded organization, it's very much up to the country of origin for them to prioritize what's very highly important for them for national scientific significance or for national priorities. And Mr. Fadness actually referred to that earlier on when he talked about soliciting applications from all across India. There's also then a tremendously complicated juggling act that takes place amongst Axiom and with all of our crews and with our teams and with our implementation partners, as we have to figure out what facilities are available during a 2-week mission. Can the crew get access to them? Does the crew have time to do them? If it's human-related research, the crew actually has to consent to take part in it, and because it's human subjects research, do they have the time to do that? Are they allowed by the flight surgeons to actually take part in it if there's limits, for example, on the amount of blood that an astronaut can give for a number of experiments? So all that means that you have not only the scientific priorities of our customers that comes into play, but also then the juggling act of figuring out what's feasible and how we can actually make it all work within a very short time frame. So that's sort of part of the thinking that goes into that. But Jeff, let me check if that answered your question appropriately.
It does. Thank you.
We now have Hubert Kijek.
Here is Hubert Kijek from TV124 Poland, and question for Monika Banaszek-Zimmerman. Well, which specific Polish experiments or technologies on Ax-4 do you find most promising in terms of potential application on Earth or in future space mission when we talk about Polish experiments and technologies? And what is the significance of the participation of Polish experiments in Ax-4 for Poland's long-term space strategy? And what is the significance of this mission for Poland's economy and scientific community? Thank you.
Okay, thank you for these questions. So starting with the applications on Earth and in our future space missions, I could see the several experiments that stand out as the one. So for instance, we can see the Leopard ISS, a Polish AI hardware demonstrator that could support real-time data processing during deep space mission. There's also the photograph and EEG neurofeedback explore brain-computer interfaces and stress mitigation with potential applications in both astronaut mental health and clinical care on Earth. So these are some of the examples. On the biotech side, we have the experiment called the tardigrade gene and space volcanic algae that could play a role in future life support systems for long-term habitation on the moon, on Earth, Mars. So each of those experiments is a leap forward, not just in science, but also in the way that we think about the present and sustainability in space and on Earth. So I hope that this gives you the answer about the some examples of the experiments that in the future could be also used on Earth. When it comes to the area of research that you have asked about and the opportunities that we see in the global market and the economy, of course, being a part of the Axiom Mission is a big opportunity for Poland and for the growth and also for the technology development and the science development as well. So this is quite a strong collaboration between different partners, and the results of the mission can significantly increase our presence in the missions on Earth orbit, on space development. So this can simply be translated into the investments and the benefits that we will achieve from the economic point of view. And thanks to this opportunity and making the experiments, we can build our capabilities in developing the critical capabilities in space, which are like the monitoring system mentioned, the autonomous AI processing, so and advanced material science that we have the experiment also. These are the contributions that can be in the future used in lunar or commercial missions that will be required to conduct those missions. So Polish entities, industry, and scientific community can be very much present on the ISS missions.
And thank you. All right, next in line is Josh Dinner.
Hi, Josh Dinner, space.com. Thanks for doing this. I actually have some follow-up questions about the diabetes research. Are you able to identify what brand CGM y'all will be using? And how exactly is that data being transmitted to the ground? Will the numbers be monitored in real time? Will they be monitored periodically? And will they be monitored in space as well? And you mentioned bringing insulin pens into orbit. Will any of the astronauts with CGMs be injecting insulin, or is this just to see how the insulin responds in microgravity? Thanks.
Thank you for your question. So we are using more than one brand to get the data when it comes to the continuous glucose monitors. And the data is being monitored while the patients, of course, are wearing them, and when they come down. There is also a way to validate these readings with blood, so that will be both tests done, again, just to make sure with the effect of the space and microgravity, even the adhesion might be an issue. So we want to make sure that we validate the readings. Well, insulin pens, no, there will be no astronaut will inject insulin at all. This again, the intention is just to test the viability and the stability. So these insulin pens will be tested on the ground, and then after they come back from the flight, to make sure that the effect of the microgravity and everything in the space is still there, viable, and hopefully the data will show. And we'll see based on that. We'll determine whether they're still viable or not for any future missions for any insulin dependent type 2 diabetic astronauts.
Yes, thank you. And just to add, we are also testing the extrusion of the insulin pens on orbit. So this is an extension of what we've actually done on a previous Virgin Galactic flight with previous crew. So it's really important to be able to show that in multiple different environments in microgravity, that the actual amount of insulin that's being administered should need to be administered is accurate. So there's a technology demonstration from that perspective as well. Thank you.
Awesome. Thank you so much. Next in line is Piotr Zizkliovac.
All right. So my question is for Ms. Banaszek-Zimmerman. Are experiments that Sławosz is going to conduct on the ISS are already scheduled? So can you tell us what is he going to do first, second, etc.? And also, are you confident that the time that Sławosz will spend on ISS is going to be sufficient to complete the whole planned science program?
Thank you for these questions. Yes, the plan and the time of the astronauts is carefully conducted and planned by ESA team, because they are completing the mission for us, and they're coordinating the activities with all the astronauts and the experiments and the complement that we are providing. So Sławosz will be very busy, not only with the scientific and technological experiment, but also the other parts of the mission, of the Ignis mission that is foreseen. So the educational experiments and activities connected with the communication. So he will be very busy, but all the efforts of the people responsible for the coordination of the mission are put to make it possible. Also, for sure, it will be coordinated in the live mode, and depending on some changes that may happen in the schedule. But everything is well planned, second to second, so that he is able to conduct the experiments. So I hope this gives you the answer for our feeling that everything will be done and that the science will be achieved after the mission. Was there any other?
Is it possible for you to tell me, for example, which experiment is going to be first?
Honestly, no. It will depend on the accommodation of astronauts on the ISS. So I believe that everything will be provided to you after the mission, how it was done, how it was conducted. So I do not have this detailed knowledge right now in front of me.
Crew has an extraordinarily tight timeline on such a short mission. So they have everything planned out very carefully in quite short increments of time. I think it's 5 or 10 minutes where they have their time scheduled and booked up already. But things can change very rapidly. There is a tremendous team, both at Axiom and NASA and ESA and from all of our partners, that monitors the crew activities very carefully. Sometimes things go wrong. Sometimes things take longer than expected. And so timelines get shuffled around. So what that means is that there's an enormous amount of flexibility that has to be accommodated when performing science in space as well. So it might be a plan that something will happen at the beginning of the mission, but if it's quite a short experiment, it might have to get pushed a few days later. If something happens on station that's a crew emergency or that takes priority, then obviously the research might get paused, and then the crew will come back to that later. So all that to say is that it's extraordinarily complicated to schedule all of the research that takes place, but we'll be happy to share all of the details as the mission takes place and certainly afterwards. Thank you.
And thank you, Lucie. All right, I'm going to read another question from the chat. This one is from Marianne Krupinsta from Hungary. This is for Dr. Nagy. What direction might the situation of the Hungarian space industry take following the mission? And at what stage will the results of the experiments be ready for implementation in Earth-based applications?
Thank you for the questions. First of all, I have to tell that Hungary has a rich history of space research spanning almost 80 years, including Zoltán Baj's moon radar experiment and Todor Kálmán's achievement in aerodynamics. And for example, the Pillet dosimeter still plays an important role in measuring cosmic radiation on the ISS, helping to protect astronauts. Our objective, the HUNOR program's objective, is to support space-related research and development projects and help companies enter into the international markets and the universities to make scientific collaborations worldwide. So we are investigating into the education, building partnerships with space agencies and private companies, and inspiring the next generation of scientists and engineers. And we are also aimed to promote STEM among young people. So it's an important aspect of this mission. And to your second question, let me answer with two examples, because we have a very novel dosimetry device. We can monitor the crew radiation exposure and environmental conditions during the mission continuously, and this device will track all the important parameters of the environment, such as temperature, humidity, air pressure, carbon dioxide levels, and so on. And for example, this device, I think, has a very good Earth-based application, for example, in medical situations. And the other one, the white prick experiment that will study plant germination, microgreen production, and leaf development in microgravity. And the results could also impact in agricultural sectors on Earth as well, particularly in resource-poor or urban farming environments.
Next in line is Kalyan Ray.
This is a question to Mr. Fadnis. The three of the 7 Indian experiments are related to the food. Because why it is so? And is there any issue with currently the kind of food being supplied to the astronaut at ISS?
No, there is no issue with the type of food supply. But we would like to explore specifically the India-centric food. For example, we have a sprouting experiment which tries to sprout green gram or moong, and methi, fenugreek, which is believed to have medicinal properties. The idea is to not just to stop there, sprout it, because it's sprouting, we believe, is one of the nutrition-rich, sprouts are one of the nutrition-rich food for astronauts. Then the idea is also to see how these specific India-specific sprouts, how they behave. The specimens, when they come back, they'll undergo a lot of analysis in the labs of the PIs to find out how the microgravity is affected. Similarly, other food experiment on the seeds, we plan to carry seeds from the food crop seeds, from cereals to pulse to oil seed to vegetable. Here again, idea is to expose the seeds to the microgravity conditions and they bring them back. And when they're brought back to Earth, they'll be cultivated in plants, not just once, but over generations, to see how the seeds. This will be a foundation for space farming of future, wherein how the microgravity affects the seeds, one, and then how the plants respond to the stress of microgravity. So it is not that the food what is supplied is not good, but it's towards building our own portfolio for for space food and for nutrition.
And thank you, Mr. Fatness. I believe we have time for one more question. We will take Slavoj Nagy.
I'm Slavoj Nagy from Space Junkie YouTube channel from Hungary. First of all, we'd like to say what an amazing scientific research portfolio. Congratulations to Axiom Space and to all the participating countries. And we are eagerly waiting for the launch day. First part of my question is for Balázs Nagy. Almost half of the experiments belong to Honor program, which is alone a staggering number. What were the selection criteria for choosing experiments for the Honor scientific portfolio? And also, does Tibor Kapu have a favorite experiment he is looking forward to the most to carry out?
Thank you for your question. For the first part, I would say at the end of 2023, we completed a selection process on payloads, and independent and international reviewers were the ones who helped us select this portfolio, and including ESA and Axiom experts, and they assessed the scientific value of the proposals we received, and based on their evaluation, we tried to solve the classic knapsack problem with constraints related to mass, volume, crew time, and of course cost, while try to maximize the scientific value of the whole portfolio. And the second part of your question, Tibor's favorite experiment, I bet it will be the Dairos, because it's a very interesting and funny experiment, because we want to simulate a planet-scale atmospheric dynamics with a spinning water sphere in microgravity, and I think it will be very interesting to see how can we do it. Thank you.
So hopefully we will find out how the hexagon is formed on the Saturn, right?
Exactly.
Thank you.
Exactly.
Mm-hmm. Thank you very much.
And thank you. So that's all we have time for today. Thank you so much for joining us. For any follow-up questions, please email media@axiomspace.com. With that, go Ax-4.